So in last lecture we have seen about this private versus public address selection criteria, right? So what do you mean by the public IP addresses? What do you mean by the private IP addresses that we have discussed, right? Also we have seen this particular determine the size of the network, right? And in that case also we have listed some of the questions in front of you. So how the network designer must know the size of the network, right? And depending upon that, how he or she can design that particular network, right? Also I have demonstrated you about this particular NAT, that is network address translation, in order to know the what you mean how you are going to map with the private IP to the public IPs, right? And how is going to be used in designing network, right? How it will be giving you a security and reliability to your network, right? That are also we have discussed. Okay, so in today's session we will see about this particular different size of your individual locations, right? So the network designer must understood the different network locations where it is exactly, right? And how, what are the internet working devices and all that will be used in that particular network, right? Then we will discuss about this planning the IP addressing hierarchy, and in that we will discuss what do you mean by the hierarchical addressing, right? What do you mean by the root summarization, the CIDR CDIR range, then IP addressing hierarchy criteria, right? So all these things we will discuss in that particular topic, right? Then the benefits of this particular hierarchical addressing, right? So if you are doing the hierarchical addressing in your particular organization, right, then what will be the impact on it in for your organization? What are the different benefits you have by applying this particular addressing, right? So that also we will see. Then impact of poorly designed IP addressing, right? So if you are not able to design the IP addressing properly, then right, then what are the consequences you will face in while you are designing in future, right? If you are going to add, or you are going to scale your network, you are going to upgrade your network, right? At the time of that, what will be the impact of that, right? If you are designing your particular network with this particular poorly designed, right? That also we will see. Then we will see this how this particular fixed and variable length subnet mask will be there, and also we will discuss about the classful and classless routing and what is the difference in between both, right? So and after that we will see this particular hierarchical IP addressing and summarization plan example, if time permits, right? Then we will cover this. Otherwise we will continue with this with the next session, right? And also the last one is nothing but how you are going to assign the IP addresses, right? So static versus dynamic, and how you are going to use this particular naming resolution as well, right? So static and dynamic DNS, how you are going to apply on designing the your particular network, right? So all these things we need to discuss, right? So let's see how much we are covered in today's session, right? So let's start with the point where we have discussed in last session, right? So yes, so here we have discussed about the where you are going to use this particular private and public network IP addresses, right, in your particular enterprise network, right? So now we will see how you are going to able to discuss about this particular network topology, right? Because if you see whoever is designing the network, right, so that is network designer, right, should acquire a general picture of your network topology, right? He or she must understand what exactly the required information is there with respect to your organization network, right? And it will be help to determine correct information to gather about the network sizes as well, right, with respect to your IP addressing plan. if you see in this particular diagram also, right? So we have here the main offices, regional offices, the remote offices, right? And all are connected with each other, if you see, right? So San Francisco is there, the Denver, the Houston is there, and all that thing. These are the some we can call as the locations in US, right? So in that particular location, that particular organization having some branches, and that are connected with each other in this particular sample network topology, if you consider, right? And if you consider here, what I'm going to do is I'm going to create some of the nodes from this particular network topology, right? I have listed down some of the things. For example, how many locations are there, right? What are the data types are there, what are their interconnected to which kind of the locations over there, right? So depending upon these particular thing, right, you can have a general idea about the locations, right, and how you are going to apply this particular IP addressing plan over there, right? So that will be very much clear, right, when you have a very much general picture of this particular network topology in this way, right? So if you wanted to design any kind of the network of your organization, right, the first of all you just draw the simple sample network topology over there, right? So it will be give you an idea overall the locations of these particular interconnecting branch offices over there, right? So it will be helps you to design the network very efficiently, right? Then we will move towards this particular size of the individual locations, right? So the size of the individual location is nothing but the wherever you are going to be establish your branch of your organization or your network, right? So what is the network size of that particular location, right? That in terms of what, in terms of IP addressing plan you need to think, right? So which will be obviously related to your number of end devices you are going to use, number of interfaces you are going to use, which will be required, and IP addresses, right? So to establish the overall network sizes, right, so that particular network designer must determine the approximate number of how many number of workstations will be there, how many numbers of Cisco IP phones you are going to use, how many router interfaces you are going to use, whether the switch management will be there, if it is there, whether it will be layer 3 interfaces or not, right, whether you are going to use the firewall interfaces or not, right, or any other networking devices for each and every location, right, whatever you have we have discussed in this particular network simple sample network topology, right? So on each of these particular location you need to find out all these things, right? And after that it will be so that is nothing but one IP requirements, right? And by using that particular sample topology you have come to know that how many these are there, and how additional addresses also you wanted to reserve to allow the scalable network in the future case, right? So it will be helpful for you in that respect, right? So what you need to do is, so I have given here one sample table, if you see, right? So in that sample table also I have listed out some of the locations, right, their office types, whether it will be a main branch, whether it will be a regional branch, or whether they are going to access that particular organizational resources from the remotely, right? So depending upon that we have differentiate in between these particular locations and their office types, right? How many workstations are there in that particular offices, how many servers, IP phones, router interfaces, then switches, firewalls, right, and how many IPs they have in a reserved state, right? So that will be used in the future, right? And so total number of things which will be respectively for this particular San Francisco, that is 1290, right? So depending upon that you are going to calculate for each and every location, right? Each and every depending upon your office type, depending upon the number of workstation, IP phones, number of switches, and all that things, right? So you will know now what are the different internet networking devices devices they are going to use, what are the interfaces they are going to use, and how many number of IP addresses they will require, right, in each and every locations, right. So if you got this particular IP addressing requirements, right, then it will be very easy to you to design a network or allocating the IP addressing plan with respect to that, right. So that's why this particular size of individual location you need to first of all determine, right. So I have determined here for each and every location which we are already seen in this particular sample topology also, right. So I have listed here first of all locations, their types, right, and in that I have calculated their size of the individual locations, right. I hope you understood this, right. Then we will move towards this, the planning of your IP addressing hierarchy, right. So if you see IP addressing hierarchy, it is nothing but for we are talking about with respect to your network routing here, right. So because this particular IP addressing hierarchy can reduce the routing overhead over here, right. So if you see in hierarchical addressing, first of all we will discuss, right. So in hierarchical addressing, the best example if I wanted to give is that is nothing but your telephone number system, right. It is nothing but your hierarchical system, right. So because if you see it's having some of the country code, the area code, the local exchange, and then you will get the line number and all that things, right. So before so all these things are with respect to your telephone numbering system, right. So this particular telephone architecture it will be handle some prefix routing, we can call it as, right. So prefix routing, it will be it will be used for different locations, right, to connect with that particular phone line, and accordingly it will be used, right. So if the distance is very long, then that particular carrier, right, so whichever service provider is there, right, so that must understood or that must recognize the area code of that particular location, right, and by using that area code it will be reached to that particular specific line, right, and then it will be connected with you with that particular telephone line, right, and accordingly it will be happen. Okay, then this particular IP addressing scheme which we are talking about, right, this is also a hierarchical one, right, and prefix routing is also will be there in IP addressing, right. So IP routers will be take the decision with respect to this particular hierarchical one, right. So because if only router have know only about the how to reach to the next hop, right, it does not have to know that details of how to reach to the end node that is not a local or what, right. So router uses this particular prefix, right, to determine the path, and for that particular destination addresses that is not local, and accordingly it will be send the traffic to the over that particular hop, right. So in this way these particular routers will be useful in by using this particular prefix routing, it will be used in this particular hierarchical addressing over here, right. Then the next one is your the route summarization. So if you we can also call it as an route aggregation, right, or also we can call it as an supernetting, right. So you know already the subnetting part, right. So so supernetting is also one of the concept, right. So we will talk about it later on. Okay, so one route which will be there in a routing table, for example, which will be representing many other routes, right. So that will be happen for if you see the routing table of any kind of the router, right, which having representing many other routes, right. So this summarizing that particular routes will be reduces the routing update traffic, right. So because if you know the routing table will be automatically get updated, right, but if you using this particular route summarization, right, so that will be summarization routes, it will be reducing all this kind of the stuff which will be update this particular traffic, and reduces the number of routes in that particular routing table, right. And also overall router overhead also will be become minimum, right, in that case, right? So that's why this particular route summarization will be root, right? And if you use this effective use of this particular route summarization, which will be also limit the impact of topology changes to the routers, right, for that particular network, if you consider, right? So so if that particular internet which will be using, right, it will be not adapted this particular route summarization, right, on this particular CIDR, right? So I think it would be not, you are not going to use the internet any kind of in any manner, right? So if you see, this particular route summarization will be take place in each and every phases over nowadays, right, and in ISP's level at most, right? Then we will see the CIDR, right? So this already right? So classless interdomain routing is there, right? Which will be help to cultivate the problem of, one second. Okay, so it will be help to alleviate the problem of IP addresses exhaustion, right, to the growth of the routing tables, if you see, right? So what is the idea behind this particular CIDR if you are going to use, right? It is nothing but multiple addresses over there, right? For example, if you take the block of class C addresses, right, which will be combined, which will be aggregated, which will create a large classless set of IP addresses, for example, right? And this particular block of class C networks, network numbers are allocated to each network service provider, right? And organization using this particular network service provider for internet connectivity are allocate these particular subsets from that particular service provider, which were you are going to use, right? And these particular multiple class C addresses can then be summarized in a routing table, and which will be used for this particular route advertisement, right? So in that way, this particular CIDR will be helps for this particular route summarization, right? And okay, and it will be also you can call it as a route aggregation strategy, right, or a route summarization strategy, right? So if you see, it will be having some of the multiple IP addresses must share same leftmost bit and all. Some of the requirements the CID are also having to work for this particular summarization correctly, right? So there are some prerequisite for that also, right? So that must you will be fulfilled, right? So I just list out some. For example, the multiple IP addresses must share the same leftmost bit. Routers must base their routing decisions on a 32-bit IP addresses and a prefix length of 32-bit, right? Routing protocols must carry the prefix length of 32-bit IP and all that things, right? So depending upon that, it will be useful for just route summarization part, right? Then we will see this particular IP addressing hierarchy criteria, right? So how this particular IP address hierarchy is an important impact on routing protocol, right? So we will see. So these are the some questions which I have listed over here, right? So it will be it will be useful for you to decision about how to implement this particular IP addressing hierarchy, which will be depending upon these particular questions, right? So for example, the first one is hierarchy needed within the IP addressing plan, right? So whatever IP addressing plan you have, right? So we already discussed in our last slide, right? So you need to first of all finding out the as per the location, the size of the individual location, right? So what are the internet networking devices you are going to use, what are the interfaces you are going to use, what are the free reserved IP addresses you are going to take, right? So depending upon that, you need to plan your IP addressing, right? So in that IP addressing plan, also you need to check whether this hierarchy is needed for that or not, right? Then what are the criteria for dividing your network into this root summarization groups that we have also given one example over here with the help of this particular CIDR of class C addresses, right, which we are coming from this particular ISPs to you as a class C addresses, right. So that also you need to check the what are the different criteria you are going to apply for this particular dividing the network into the root summarization group, right. Then how this particular okay, that is covered. Then is a hierarchy of root summarization group is required, right. So whether hierarchy of root summarization is also required or not, right. So we know now the hierarchy of IP addressing, right, but what about hierarchy of this particular root summarization? It will be also required or not, right. That also you need to find out. Then how many end systems does each root summarization group or subgroup contain, right. So how many end systems does each root summarization group or subgroup contain, right. That means, for example, if you see in this particular individual locations, right. So in individual locations, right, how many number of at each office type, how many numbers of internet working interfaces devices will be used, which will be required by the which will be required for IP addresses, right. And whether the root summarization can be it will be contained or not, right. That also you can find out, right. So depending upon that, you can check this particular IP addressing hierarchy, right. And yes, then we will see about this particular benefits of this particular hierarchical addresses, right. So network designer which will be deciding how to implement this particular IP addressing hierarchy, right, based upon obviously the network sizes, the geography, and the topology, their location, right. So depending upon that, to provide a stable kind of the network, this particular IP addressing hierarchy will be implemented, right. And for that there are some parameters which will be helpful, right. For example, if you see the influence of IP addressing on routing, right. So for an IP addressing which will IP addressing plan, right, which will be you are going to do, right. So it will be depending upon this overall the routing of that particular network, right. So before allocating blocks of IP addresses to various parts of the network and assigning IP addresses to devices, right, consider the criteria. You need to consider the criteria for an appropriate and effective IP addressing scheme, right. Because of that only whenever you are going to design any kind of the network, right, so that routing stability, service availability, scalability, then modularity of your network, right, all these particular network characteristics are directly affected by this particular IP addressing scheme, right. So these particular IP addressing allocation and deployment can be useful when if you are going to use this particular hierarchical addressing over there, right. Then the modular design and the scalable solution. So in these, if you building a new kind of a network or adding a new kind of the service on the top of your existing infrastructure, right, this a modular design which will be helps you to deliver a long-term scalable solutions, right. And if you are talking about this IP addressing hierarchical model, right, so IP addressing this modularity allows the aggregation, the routing information on hierarchical basis as well, right. So it will be one advantage for this particular hierarchical addressing. If you are going to use, you will get it the modular design and scalable solution for that, right. And also we have talked about the root summarization part. So that is nothing but your root aggregation over here, right. So it will be reducing routing overhead and improve routing scalability as well as the stability, if you see, right. So to implement this particular route aggregation, right, so that designer also must be able to divide the network into contiguous IP addresses, areas, right? For example, if you are going to use this particular 192 to 168.1.1 to 1.50, right, then obviously the next subnet should be from the 151 to 151 to 200 and all that things, right? So it must be the contiguous one, right? So it will be help you to root aggregation, right? So depending upon that, this particular summarization groups will be done, right? And you can use this you can reduce this routing overhead also in a large network if you are going to use this particular hierarchical addressing, if you're talking about, right? Then we will see this particular if you see this particular diagram, right? So over here we have and the three levels over here: the first level, second level, and the third level, right? So if you consider the first level, in which this particular network locations which we are giving, right? So location 1, location 2, right? So all these location typically the hierarchy of this particular enterprise network will be done, right? So group of the summarized subnets will be done, right? So we can call it as a summarization groups over here in the first level, right? So location the network locations will be summarized in the first level, right? And for the second level, if you see, it will be done within that particular first level summarization, right? So whatever the location you have summarized in the first level, that also gets summarized or aggregate in that particular second level, right? So it will be represented if you see in this particular diagram, right? So the different kinds of the buildings over there, right? Different kinds of the sections over there, right? So that particular sections also aggregate in that particular level 2, right? And the next one is the third level, right? So it will be also used to reduce the potential routing overhead over there, right? So it will be exist second level summarization group, right? So if you see here the section or floors in that particular building, right? Individual buildings, right, which will be represented as your third level of summarization group, right? So first level is your location, right? Second group summarization is your building 1, building 2 and all, and the third level of summarization is nothing but your sections are within that particular building, right? So these three levels over there which will be used to decide the IP addressing hierarchy over there, right? Then we will see the how impact of poorly designed IP addressing over there, right? For what will the result of this particular thing, right? So if you see this particular poorly designed IP addressing, right, it will be result in IP address that are randomly assigned as whenever we are going to need it, right? For example, if you wanted to develop a new laboratory in our college, right, you are going to provide randomly IP addresses over there, right? If you are not also using one DSCP pool and all DSCP for allocating IP addresses and all that things, right? So whenever the systems you are going to add in our laboratory, right, you are giving randomly IP addresses over there, right? And if you wanted to next for example now the 303 lab, right, and then also you are going to added different PCs and also allocating a randomly IP address. So that is not a good sign for the scalability, that for troubleshooting and for all that part, right? So that is nothing but the poor design of your IP addressing, right? So whenever you are needed, you are going to randomly assign the IP addresses. That is must not be the case, right? So what you need to do is because in that case you are not going to summarize, you are not going to aggregate all these particular IP addresses, you are not going to subnet your network, divide your network, right? So this is nothing but the poorly designed we can call it as an IP addressing scheme, right? And because if you are going you are not going to use the dynamic allocation, dynamic routing protocols over there, right? Because of that you are just um, restrict to use this particular static routing and static IP addressing allocation. That means each and everything you need to each and everything you need to do or manually, right? So it will be not suggested, right? So what you so if you see the impacts of it, right? So whenever if you the first impact, if you see, the excess routing traffic consumes bandwidth, obviously, right? So when any route changes, any routers will be sending where any routers will be sending routing updates over there, right? Without summarization, more updates are sent and the routing traffic consumes more bandwidth, right? So if you are not able to do the summarization in the routing traffic, right? So obviously the more routing traffic will be there, and therefore it will be consumed more bandwidth over there, right? Then if you see the increased routing table recalculations, obviously if routing updates will be required, obviously you know that for calculating the base path, right? But calculating the base route, right, routers needs to update their routing tables, right? They need to recalculate, right, which affects the router's performance also, right? It will be also affect on their forwarding traffic also, right? So this will be causes for that particular rework will be there, right, for the routers, right? And the third one is possibility of routing loops, right? So whenever too many routing changes, right, will be prevent from routers from converging their neighbors, right? So it will be routing loops might be occurs, which will be having some failure in your consequences for in your organization, right? So most of the time we will be seeing this particular thing in organization, that so the routing loops will be there, right? And because of that there must be very much harm to the that particular organizations will be also there, right? So these are the some impacts which will be happen with because of this particular purely designed IP addressing scheme, right? Then we will see these particular benefits of the route aggregation, if you see, right? So in this particular diagram, if you see, which will be an example of implementing route summarization, right? So which will be an area borders in this particular if you see this particular topology, right? This and if in this particular topology, if a link within that particular area will be fails, right, and the routing updates are not propagated to the rest of the network, because only the summarized route will be sent to the rest of the network and it will be not changed, then this particular route information about this particular failed link will be stays within that particular area. That reduces bandwidth consumption, right, which will be related to your routing overhead, and which will be unnecessarily routing table recalculations will be there, right? So so big and for if you see the efficient aggregation of routing advertisement, right? So if you are going to use this particular efficient aggregation part, right, then it will be narrow the scope of your routing update propagation, right? And it will be very much significantly decrease the frequency of the routing updates, and it will be useful for your route aggregation part, right? So we have also discussed the route summarization, that is nothing but the aggregation and all that things, right? So how it will be benefit to it will be helpful for less routing table recalculation will be there, right? Less overhead will be there. Then it will be reduce the frequency of routing updates and all that things, right? So that are the part. Okay, then we will see next concept, that is fixed and variable length subnet mask, right? So now it is also one of the consideration while designing IP addressing hierarchy, right? Those hierarchy which the subnet mask is used, right? Either the same mask for the entire major network if you are using, or you are going to use a different mask for the different parts of your network, right? So there are some of the routing protocols will be required this particular FLSM, right? That is fixed length subnet mask, right? Or some of allowing the VLSM, that is variable length subnet mask, right? So depending upon the organization, right? So depending upon the which routing protocols will be required, which one, right? So it will be helpful in that particular directions, right? So if you're talking about this particular FLSM, right, so fixed length subnet mask, right, which will be required all subnet of a major kind of the network, right, which having the same subnet mask, right? Therefore it is a less efficient address space allocation if you are talking about, right? So if you see in this particular diagram also, right, so FLSM I have demonstrated over here, right? So in this, if you see the whole network is using a same subnet mask, right, /24/24/24/24/24, if you see here, right? So it is nothing but here FLSM, right, fixed length variable mask. And if you see here the variable length of subnet mask, then here for router A /24, for router one second, yes, so here for serial communication is also it will be using /30 for B/24, right? So it will be using a different subnet mask for different part, right? Different address space allocation, right? So it will be giving you a greater capability to perform this particular route summarization, right? Why? Because it will be allowing you more hierarchical levels, right, within that particular addressing plan. And that's why it will be require some prefix length information, right? So it will be sent with each addresses to advertise in the routing updates, right? So that's why this particular if you see in this particular example, right, so these point to point links which having, for example, this particular subnet mask /30, which will be providing only two available host addresses, right, which is all that is needed on this particular link. And the LANs have the subnet mask of /24, right, because they have more hosts than the required addresses, right? If you see here, right, this particular LANs having /24, right, and because they have more hosts than the required addresses, right? So that's why this particular VLSM will be more useful with respect if you compare with the FLSM, right? So that is also you need to know. Okay, then we will see this particular classful and the classless routing protocol, right? So if you see in this particular diagram, right, so I have given you one diagram over here, so which will be if you're talking about first of all the classful routing protocols, right? So here in this the routing will be updates do not include the subnet mask, right? So if you see here, it will be not routing which we will be doing, right? So it will be not having the subnet mask. If you see from A to B, this particular 172.16.1.0 is having some is not included the subnet mask, right? So but if you see in the classless, right, so this is also including here the subnet mask, that is /24, right? If you see here, it is also there will be, it is not much /24 over here, right? So that is the main difference in between this classful and classless, right? So in classful, the routing updates will be not included in the subnet mask. And the second one is when a routing updates is received and the routing information about one of the routing information is about, then if you see in routes within that particular same network is configured on the receiving interface, right? And the subnet mask configured on the receiving interface is also received router also, right? So therefore the mask must be the same for all the subnet of this particular network only, right? So that is nothing but we already just talk about this, that is nothing but your FLSM, right? Fixed length subnet mask will be there, right? And router, if you are using for the different network, then configuration of that particular same interfaces, right? Then your default major network mask, that means your default network mask will be assumed to apply to that particular relevant routes, right? Therefore it will be automatic route summarization will be performed, right? On the boundaries through on the network boundaries, and subnet the network must be your contiguous one, right? So that will be your classful routing protocols would be there, right? And if you see in the classless routing protocol, right, so in classless obviously the VLSM we are going to support. If you see here, the variable length subnet mask will be supported, right? The routing updates include the subnet mask, as I already told you, right? And then automatic route summarization at the major network boundary is not required over here, right? So route summarization can be manually configured in classless routing protocols, right? And also subnetted network can be discontinuous, right? It will be depending upon organization how they are going to, how they are wanted to perform it, right? So all the major modern networks, if you see, right, so all are going nowadays using this particular classless routing only, right? And if you're talking about the routing protocols with respect to this particular classless routing, then you will consider the RIP, then EIGRP, that is enhanced interior gateway routing protocol, then OSPF, that is open shortest path first routing protocol, then border gateway protocol, that is BGP, right? So all these are nothing but some of the examples over here with respect to this particular classless routing protocol is concerned, right? So this is classless and the classful routing protocols over here, right? So this is then we will have this hierarchical IP addressing and summarization plan, but we will discuss this in our next session, right? So we have end up with this particular classful and classless routing itself by today, okay? So we will continue from hierarchical IP addressing and how you are going to and what are the different methods of assigning IP addresses in our next session, right? So what we have covered today is so we have discussed about the how the size of the individual locations will be calculated, right? How the planning of IP addressing hierarchy can be done, right? What do you mean by the route summarization? What do you mean by the hierarchical addressing? What do you mean by the CIDR, IP addressing hierarchy criteria? Also we have discussed. We have also seen what are the different benefits of hierarchical addressing, then what are the impact of if you are going to design IP addressing poorly, right? That means if you are going to assign the IP address randomly to each and every internet fucking devices, right, then there will be no meaning over there, right? The route summarization can't be happen, then routing table also will be disturbed, right? And there will be no scope for you for the scalability and all that things, right? There, because of that you are not going to use their DSCP and all that things, right? So also we have discussed the fixed length subnet mask, FLSM and VLSM, right? Variable length subnet mask. And also we have discussed classful and classless routing protocols, right? So in a classless we can use this particular variable length subnet mask, right? And for the routing protocol, if you concern about this, that then the all the modern routing protocol, for example RIP, that are all the dynamic routing protocols, right? So RIP is there, EIGRP is there, OSPF is there, BGP is there, right? So all these kind of the routing protocols are to be used in this particular classless routing protocols, right? So this also we have discussed, okay? So in next lecture we will see about this particular hierarchical IP addressing and summarization plan and the methods of assigning IP addresses, and also we will see some of the demonstration of how you are going to assign the IP addresses dynamically, right? so that is also we will discussed. Okay, so that's it for today's session. Okay, thank you for joining.